Welcome to Ask and Learn.
So here we're going to understand why a longer cannon is going to provide more speed to a cannonball than a shorter one. To do that, we have to first understand the principle of impulse, in which impulse is going to be equal to force multiplied by the time that this force is applied, which is also equivalent to the change in momentum, or mass times velocity. So because a shorter cannon is going to have a smaller path for the cannonball to travel, we know that the cannonball is going to be inside of the cannon for a shorter time. So in here, we can say that we can call the time that the ball is going to be inside of the cannon T1, or delta T1, and the time the cannon is going to be inside of the cannon 2, delta T2. So if we just calculate the impulse for both cases, for case 1, we get impulse 1 is going to be F times the interval of time in T1 here, and the second one, F times interval of time in T2. If we say that the forces are the same, the force exerted by the cannon is the same in both cases, then since we know that T1 is going to be smaller than T2, we can already infer that I1 is going to be smaller than I2, or the impulse in the second case is going to be bigger than the impulse in the first case. So if we look at the changing momentum, so delta mv case 1 is going to be smaller than delta mv in case 2. If we assume that both cannonballs have the same mass, we can also infer that V1 is going to be smaller than V2, and that's how we know that that's how we know that the cannonball in the second case is going to be faster than the cannonball in the first place.